I'm Anil Kumar, and in this video we'll try to understand how to write general solution for a trigonometric equation. So we'll begin with a very simple example, and this time we'll take all the primary functions, trigonometric functions, as equal to 1, and we'll find general solution for these. So we have here sin x equals to 1, cos x equals to 1, and tan x equals to 1. When I say sin x is equal to 1, it really means that sin x is basically defined as in a right triangle, opposite side over hypotenuse, right? So in a right triangle, opposite side equals to 1. That is what in a right triangle, opposite side is equals to hypotenuse will give us sin x is equals to 1. Let's see what it means on a coordinate system. So if I have a right triangle here, let's say we have a vertex at the origin, and that's the triangle for us. Now if we want, opposite side is the side there and that hypotenuse. Now if we want both of them to be equal, it is only possible at a point along the y-axis. So when you are on the y-axis, then only opposite side is equals to hypotenuse. Therefore, in 360 degrees or in one full circle, there is only one possible solution, and we say x is equals to 90 degrees, or we can say x equals to pi by 2. So these are the solutions in degrees or in radians. Now we need to provide with general solution. General solution means when will the next time this will happen. Now since sine waves, all trigonometric waves, are periodic in nature, and the period for sin x is 2 pi or 360 degrees, we can say after every circle it will be 1 when it comes to this point, right? So even after one full circle at this point, which will be 90 plus 360, it is going to be 1. So in general, I can write general solution as 90 degrees plus n times 360 degrees. Or I could write pi by 2 plus n pi. So that becomes a general solution for sin x equals to 1. So that is how we can find general solution. You could also look into graph of sin x and then figure out the solution. Sin x graph is kind of like this. So in general, you find it is 1 for pi by 2. So the first solution is pi by 2, and of course, since it repeats, every pi by 2 after one full cycle will result into 1 value for sin x. So that's how we can find the solution for sin x. Now let's look into cos x. Cos x is equal to adjacent side over hypotenuse. That means in this particular case, what we are looking into is a triangle whose position is such that adjacent side is equals to hypotenuse, and that is possible only if the triangle is along the x-axis, right? Then only it is 1, right? So that is when x is equals to 0. So that's one way of looking into it. The other way is into the graph of cosine x, correct? So the graph of cosine x is kind of like this. So from the graph also, you can find that cos x is 1 at 0 and at 360 degrees, or 2 pi at the end of the cycle. That means when it completes the rotation. Do you see that? So after every cycle, cos x will be 1, right? So we can have a general solution as x equals to 0 or multiples of one cycle, which is 360 degrees when you're talking about in degrees. So we can write 360n, or we could say it is n times, let me write 2n times pi, right? So it's good to write the numbers before the variable part. So 2n pi is a better way of writing. So these are the general solutions for cos x equals to 1. Now tan x equals to 1. Tan x equals to 1, let me show you using the calculator, and we will use the cast rule. So those are good rules to use whenever in general we are trying to find the solution. If you use calculator, then tan x equals to 1 means x equals to tan inverse of 1, right? So we can use the calculator and find inverse of 1. So tan inverse of 1 is equals to pi by 4. If I convert it to degrees, I will get 45 degrees. So I get x is equals to 45 degrees, or as I showed you here, it is pi by 4 when the calculator is in radians. So for x equals to 1, we get one answer. Whenever you use calculator, you'll always get just one answer. You will not get general solution, correct? Now how to find general solution? Let's look into it once again. To find general solution, we should know cast rule, right? Or we should know when is tan positive in a coordinate plane. Tan is positive in quadrant 1 and in quadrant 4, correct? So tan equals to 1 means position is kind of like this, right? So where, adjacent side and these two sides are equal. Now these two sides are equal only when you are at 45 degrees, correct? That's an isosceles right triangle. Is that okay? So for that position, tan is 1. But tan will be 1 in one full cycle 2 times. Once when it is in quadrant 1, the other time it is in quadrant 4. Or you can say that the time period for tan is pi. You should know that period for tan is pi. That means it repeats after every pi, or we should say 180 degrees when we are considering degrees. Therefore, the general solution becomes 45 degrees plus n times 180 degrees. We can say 180 degrees times n, or n times pi. So that becomes a general solution where n belongs to integer. So all my equations, wherever I write general solution, n will be integers, right? So that is how you can find general solution for a trigonometric equation. I hope you understand and appreciate that we could adopt different approaches. We can find the answer with the help of a calculator. Most of the time we find the related acute angle, and then using the cast rule we can generalize it, right? Or we can find the solution using the graph of the function, read from the graph, and then generalize it using our knowledge about cast rule and periodicity of the function. We'll follow these strategies and do a few more examples. Thank you.